Okay, there's a lens. Let me place it here. No, what to do? Prism is there. I think whenever prism, okay, ray incident, okay, no, but we have point object nearby prism. How do you can calculate all that? So if you can recollect at the end of the prism, we have discussed some problem. Suppose say if there's a prism, it's a thin prism. This is the object is kept here. Let me make you recollect. If a ray is incident, it will undergo deviation. Similarly, if a ray passes through this, it will undergo deviation. Now it will meet at a point called this is y, this is x. Then what is the deviation suffered by thin prism? That should be equal to delta. This is what we take delta, no? Yeah. So this will become delta. Then this is the prism. So delta is equal to mu minus 1 into A. This is a deviation produced by this prism. Then tan delta equal to y by x. So let me draw the ray diagram. The ray is passing through the prism. Another ray. You can pick up any ray that one. So it should be this is okay, fine, done. So this is the deviation, no? It has suffered. I'll show it here. Now what is it? There's a deviation. The ray wanted to check this. So of course, the refractive index of this is mu1. Lower part is mu2. The deviation produced by upper and lower part will be slightly different here. Let it be different. So this will be delta. If this is delta, this will be delta. I can't erase that easily. So this will be delta. Call this is y, this x. It is applicable even for the lower part also. Delta 1, I'll write it. Y1. X will be same for both the things. So with this help of this, we'll get the first the deviation. Deviation suffered by the rays above the optic axis is given by this one, A1. So mu1 is how much? 3 by 2. Angle of prism 5 degrees, 2.5 degrees. Deviation suffered by the rays passing through lower part of the prism, 4 by 3 minus 1 into 5 degrees. pi by 3. Okay, these are, sorry, we have to convert into radian, no? Pi by 180 radians. Solving this, we'll get the 0.044 radians. It's in degree, I convert it into radians. Pi by 180, I'll multiply it. Similarly, 5 by 3 into pi by 180 radians. So there's a deviation suffered by, this will become 0.03 radian. Now we'll calculate y1. What is a tan delta 1 equal to y1 by x? Or it is a very small y1 by x. So y1 equal to x into delta 1. What is value of x? 45.55 different into delta 1. Zero 0.44. Y1 equal to approximately 2 centimeter, we'll get it. That will be the image formed by the upper part of the prism. What is I1? I1 is the image formed by upper part of prism. O is object. Similarly, we'll calculate the tan delta 2. Delta 2 45.5 into delta 2 will be 0.03. 33, 45, 45, 135, 1.3 centimeter. So image will be formed just below that one. Okay, they will become object for this lens here. That I1 and I2 will become object here, I1, I1 dash. That corresponding images we have to find out, but they are not on optic axis. This is optic axis. I think initial part is what our mathematics are. First what we did is only the mathematical part. If I think I'll get some space to everything is visible for you. Similarly, image will be, I2 will be formed here. Now we should, what we should do? We should calculate, now we know I1. Sir, what about I2? I2 will be, I'll show it here. I2 here. Then this will be Y2. This will be delta 2. I'm unable to show it. The diagram will be very complicated. Now this will become I1, I2 will become object for the this diverging lens. Object distance is same. We'll calculate corresponding image distance. So we'll apply the lens equation. 1 by PO PI equal to 1 by M. What is the object distance? Total will be 45.45 point. 90 centimeter minus 90. Focal length minus 30. PO equal to 90 into 30 by minus 60. 0, 3, 2 minus 45. This distance is, so magnification, how we define PO by PI, sorry, PI by PO. PI is, what I did, symbol, or only symbol change. I didn't. 1 by V minus 1 by U equal to 1 by F. Object is at a distance of 90 centimeter. Focal length is 30. As a diverging lens, minus 30. Solving this, minus 90, 120. 0, 0, 3, 3, 4, 90 by 4. 90 divided by 4. 22.5. So magnification minus 22.5 by minus 90. Then we'll calculate the image, height of the image. Height of the image will be h1 equal to magnification into y1. Magnification into y1 is how much? 2 centimeter. So let me do calculation. So it will be 22.5 into 2 equal to 45. 45 by 90 will be 0.5. Okay, H2 equal to M into Y2. Magnification into Y2 will be 1.3. So this will be 0.325 centimeter. Where there will be final images, there will be here. At what distance? PI will be 22.5, somewhere here, and there will be positive. There will be here. So coordinates again you have to Write down the coordinates. So coordinates of image will be I1 will be 67.5 centimeter, 0.5 centimeter, and I2 will be 0.325 centimeter. Coordinates, positions. This is what is asking. Can you show that in the diagram so that it will be clear? I'll 44. This length was how much? 44.5 centimeter. This is the optic axis, sir. The images will be somewhere here. 67. This will be I1. This will be I2. Okay.